Hi everyone, my name is Binay and my partner is Zeeshan Raja. Today we are here to present our capstone project report presentation, which is based on our research on wireless sensor networks in healthcare. Just a quick overview of this presentation. We'll start with introduction, then how this technology works, or applications related to WSN, issues related to WSN, and then the hybrid solution that we created, and the summary. In the last few years, WSN devices have gathered great research attention. WSN applications are mainly used for monitoring ill patients, body temperature, positioning of body, and heart rate. The field of healthcare is critical considering the fact that it is a matter of life and death, and a small error can be fatal. So, keeping that in mind, it is important that the system should be efficient and should have backup in case of the faults and error. Current applications of WSN in healthcare have many issues related to it. So in this presentation, we'll try to cover all those issues.
Thank you, Binay. Hi, I'm Zeeshan, and I'm going to tell you about how the technology works. The basic system for wireless sensor networks in healthcare will have a simple configuration, but upgrades and modifications would be made to minimize errors and maximize efficiencies. Various wearable or implantable sensors will be put onto the patient's body and will be able to sense different physical attributes such as heart rate and blood pressure. The data from these sensors will be collected by a coordinator node and transmitted to the base station passing through the relay nodes. The base station will analyze the data and will be able to generate an alarm and send a notification to the physician through a medium of communication available.
WSN applications in healthcare. The first one is vital sign monitoring in hospital. With the use of WSN, networks are less evident and provide persistent network connectivity to store all the medical records. In this way, all the errors and the tangling of wires can be reduced, which also reduces the patient's anxiety. WSNs are also used for data collection for studies and clinical databases. As WSN maintains the consistency and analyze the data, which allows healthcare staff to make the better decisions because they have all the data stored. WSN can also be used for drug administration in hospitals. With the wrong medical prescription can be lessened if the medical sensor nodes are attached to medications, because the patients will have sensor nodes which would detect their allergies and prescribe medications accordingly. WSNs can also be used for monitoring in mass casualty disasters, as they are small and portable, which can be used for spontaneously notify the triage levels of various victims and can help constant track of the health status.
Thank you, Binay. Further applications of WSN in healthcare include telemonitoring of human physiological data. The physical data stored using wireless sensor networks can be kept for extensive period of time and can be used for medical examination later. By using wireless sensor networks, one can also detect and monitor all patients' behavior. By using these small sensors, the patient has a better independence of movement, and it also allows the specialist to recognize predefined symptoms beforehand. Moreover, this can simplify a higher quality of life for the patients as compared to the clinics. Another application of wireless sensor network is monitoring patients' data and allowing the doctor to track it. When using wireless sensor network applications inside a healthcare environment, typically tiny sensor nodes are attached to every patient, and every attached node performs its own specific function. For instance, one node may be used to monitor the heart rate of the patient, and the other might be used to monitor the blood pressure at the same time. Nevertheless, doctors may carry a linked wireless sensor node themselves to spot any patient within the hospital building. Another practical application of WSN is the Vital Jacket. It is an intelligent mobile device that can continuously monitor electrodiagram waves and heart rate of different fitness, high performance sports, security, and medical applications. It can transfer data via Bluetooth to a personal digital assistant or a physician.
WSN issues. The first one is security. Due to the wireless nature of the sensor applications, people using these devices can be affected by the problems caused by security threats and attacks. Attackers can be either internal or external. Attackers usually reroute the data in the healthcare and can make routing inconsistent. Attackers can also steal critical information of the patient, which can be threatening for the patients. To overcome the security issues, some sort of authentication and encryption mechanism should be used. Next one is privacy. In privacy, like when we use WSN devices, there is always a major issue in regard to how the data is obtained from the patient. Is he without the consent or is he with the consent of the patient? Without suitable privacy measures, private data may perhaps go into the public domain immediately, which would be theoretical for a number of reasons. So, to overcome the privacy issues, uh, awareness should be created and some sort of provisions should be implemented to overcome this issue. Next one is legal issues. Legal issues may also arise because the data obtained from the people is shared among different people at different places using the WSN devices. So in this, the main reason is who will be responsible to enforce regulations and who can have access to the data. In the case of misuse, who will be accountable? And the data generated from a person could also be used for illegal purposes. So, to overcome the legal issues, some sort of strict laws should be implemented and also awareness should be created. Fault tolerance. Sensor nodes in the WSN may fail or block due to the damage or the power deficiency. If they were to fail, it should not affect the whole system. And if it does fail anyways, it can cause fault tolerance issue. Fault tolerance usually helps sensor networks to be sustained without being interrupted due to the failure of nodes. So to achieve fault tolerance in WSN, scalability and energy consumption should be carefully looked at for as it is a critical area in this issue. Another one is production cost. WSN consists of great number of sensor nodes, so the cost of each single node can decide the overall cost of the WSN. WSN will not just be cost justified if the cost of the network is more compared to deploying more traditional sensor networks. To overcome this issue, cost of each node must be considered when deploying the WSN. Otherwise, it will create great upset in the budget. Next one is communication issue. High transmission is usually required by long range communication, which are normally a point to point with the risk of being overheard. To overcome the long range issue, short range transmission should be considered to lessen the chance of being overheard. Also, adaptation of multi-hop networking between sensor nodes can also lessen the communication link range.
Thank you, Vinay. Another issue that arises while the implementation of WSN in healthcare is energy consumption. Energy consumption is a major design constraint in the wireless sensor network systems, as they operate on battery. Outage of a WSN system deployed in an hospital can prove to be fatal for the patient. Consequently, all WSN devices produced should be energy efficient and should have a backup in case of low battery. Moreover, because the WSN node is a microelectronic device, it can only be fitted out with a limited power source, and replacement of power resources may be impossible in some applications. Sensor nodes are strongly dependent on battery lifetime. Each node plays a double role of data router and originator in a multi-hop ad hoc sensor network. Stoppage of the functioning of a few nodes can cause substantial alteration and might need rerouting of packets, Henceforth, it will end up consuming more power. The next issue we're going to discuss is hardware and software issue. As the entire wireless sensor should be small in size to maintain mobility, the core purpose of the system, their design is highly complex with constraints for more components on board. Keeping those factors in mind, the sensor have issues of first, low memory, second, small processor. These resources can be overcome by efficient software design. The memory necessitates the use of lean, event-driven concurrency models and precludes conventional OS designs. The code must be written carefully with efficient utilization of limited resources of onboard memory, processing, and radio communication, extending the battery lifetime. Many solutions have been proposed to overcome the issues perceived in the implementation of wireless sensor networks in healthcare. But every solution has its own drawbacks, due to which the people are still deprived of being facilitated by this innovation. Due to the limited availability of resources and lack of advanced experimenting environment, currently we could only deduce theoretical models which can be used to overcome some issues in the application of the technology. The solutions which are going to be stated are derived from extensive research on the related literature available in the pool of knowledge. The work done by various scientists and mathematicians is highly acknowledged and has proven to be very helpful. Mr. Milankovic produced a paper in 2006. In that paper, a solution was proposed to overcome the energy consumption issue by the application of the concept of power dissipation and dynamic energy management. Mr. Khan and Mr. Hughes produced another paper in 2010. In that paper, a solution was proposed to minimize power usage by optimizing the physical layer processes and the media access control layer processes. By combining both of these solutions, a system with higher power efficiency can be developed. A system that is designed using the components with minimum power dissipation and implementing the physical layer in a way to increase the probability of successful transmission of packets and applying the techniques of packet transmission scheduling and channel accessing in the MAC layer can produce a highly power efficient device which can overcome the energy consumption issue to a large extent. If that system is incorporated with the intelligent data transmission technique, it would be a breakthrough. Here I would like to state that the intelligent data transmission technique is an idea produced by me and my partner Binay. Intelligent data transmission technique is transmission of only the vital information instead of continuous data communication between the host and the server. Considering the example of blood pressure monitoring device, the device should transmit data to the server when the blood pressure increases above the flagged value or decreases below the flagged value, and the flagged value can be defined according to the patient's medical condition. This will reduce communication overhead and consequently consuming less energy. This was a presentation on research done on the issues encountered in the application of wireless sensor networks in healthcare and their solutions. I would like to thank Dr. Ather Saeed for helping us out and guiding us throughout the research program. I would like to thank Charles Sturt University for providing us the facilities to do the research. And in the end, I would like to thank all the individuals whose work has proven to be helpful in the research. Thank you for listening.